So this video involves both tables of proportional relationships and equations of proportional relationships. Something that can be really difficult for students to understand is identifying an equation to represent a real life situation or information in a table. So it says the table below shows the number of words Carrie can type over a certain amount of time in minutes. Let me fix that there. Can type over a certain amount of time in minutes. Based on the table, which equation can be used to determine the number of words W Carrie can type in M minutes? So what we notice from this table is that in 3.5 minutes, she can type 294 words, in 5 minutes, 420 words, and in 8 minutes, 672 words. We can assume this is a proportional relationship based on our equations that we have here, which are all in the form y equals kx. You don't have to worry too much about that, but it's always going to be a variable equals a number, that number being our unit rate times another variable. So what I would recommend is taking some of these numbers and dividing them. So take the number on the right, divided by the number on the left in order to find the number of words per minute, a unit rate, something that's a common theme of our proportional relationships. So I took 294 words divided by 3.5 minutes, and I got that she can type 84 words per minute. So that kind of gives us a pretty good idea of one of these two different equations to use. Sometimes students will choose D because they're like, oh, I see 3.5 here. Okay, W equals 3.5 times M since M is equal to 3.5. But this is not going to work since her unit rate, her constant of proportionality, is not 3.5 words per minute. C also doesn't work. You get that 0.01 and a longer decimal actually if you divide in the opposite or incorrect order here. So now what we need to figure out is which of these equations here makes sense. And I'm going to go ahead and cross out the ones that do not work for us. So in terms of the first equation, we're saying that the number of minutes equals 84 times the number of words. Let's think about whether or not that makes sense. In our second equation, choice B, we're saying that our words are equal to 84 times the number of minutes. Does that make sense? Well, if we take 84 times the number of minutes, does that get us the number of words that were typed? 5 times 84, does it get us 420? 8 times 84, does it get us 672? Or is it the other way around, which would be choice A, where we take 84 times the number of words, does that give us the number of minutes? I think we probably recognize that choice B makes the most sense. Now, another way we can recognize that choice B is correct is that it's 84 words per minute. The word per is typically going to represent multiplication for us, so we take 84 times the number of minutes M, which we see here, 84M, that's going to equal the number of words that can be typed. So choice B makes the most sense here. It's always good to stop and think, like put it into words yourself. Does this make sense? Is the number of words that can be typed equal to 84 times the number of minutes that we type? It sure is. So we know this equation is correct.